We are going to discuss Prim's algorithm in today's class. Here is the graph. So initially all vertices V1 to V6 are noted down and distance from V1, V2, V3, V4, V5, V6 are initialized to infinity and predecessors are marked as none and status is also temporary initially. So now if we see initial node V1, let us consider this as visited and mark the status of V1 as permanent. From V1, let us see the distances. From V1 to V2, the distance is 5. And if we compare the earlier distance infinite, it is 5 is lesser. So we are going to change this as 5. From V1, we have an edge to V3 and that distance is 14. Let us change it. And from V1, there is an edge to V5. The distance is 7. And from V1, we have an edge to V4. The distance is 9. And we do have an edge. We are not having an edge between V1 to V6. So it remains as infinity. So now let us see among all the distances 5, 14, 9 and 7, the least one is 5. So let us try to pick V2. There is an edge V2. There is a vertex V2 and we are trying to connect an edge between these two. The distance is 5. Now let us mark V2 as permanent. So now the current node becomes V2. From V2, let us visit all the temporary nodes only. Is there any node from V2 to V3? There is no direct edge. From V2 to V4, there is a direct edge, but weight of that is 11. So 9 is only lesser than 11. So we are not changing this. From V2, there is no direct edge to V5. From V2, there is a direct edge to V6 and weight of that is 3. So here infinite is changed to 3. Now the predecessor is also marked as V2. So in earlier cases also we are going to change the predecessor as V1. So now if we see among all the distances, V6 distance is less, 3 is less. So from V2 to V6, we are trying to include the edge in MST, in minimum spanning tree. So now let us consider V6 as the permanent node. We have V1, V2 and V6. Now the current node is V6. We have only 3 temporary nodes, V3, V4 and V5. Let us see from V6 to V3. Is there any direct edge? No. From V6 to V4, is there any direct edge? Yes, V6 to V4, direct edge is there and weight of that is 6. And here if we see the weight is 9. So because 6 is only smaller, we are replacing 9 with 6. And predecessor node also, we are changing it to V6. Now let us see, is there any direct edge from V6 to V5? V6 to V5, we have direct edge, but the weight is 19, which is more than 7. So we are not changing it. Now, among the nodes which are temporary, that is 7, 6, and 14. Let us see which one is of least weight. V4 is least weight. So let us try to include V4. in the permanent list category, and let us try to include the edge as well. Edge between V4 to V6. And weight of that is 6. Now V4, let us mark this as permanent. Now temporary nodes, we are left with only V3 and V5. Our current node is V4. From V4 to V5, is there any direct edge? Let us see. Yes, there is a direct edge and weight of that is 4. So now V5 weight as per the table it is 7 and 4 is lesser than 7. So we are trying to replace 7 with 4 and predecessor we are trying to mark it as 4. And let us see, is there any link to V3 from V4? V3 to V4, there is a link, direct link is there and weight of that is 2. Here it is 14, 2 is lesser than that. So we are marking it as 2 and the predecessor is marked as V4. So among the temporary nodes that are V3 and V5, the least distance is 2. So we are going to include V3 in our list of permanent nodes. So then let us try to include V3 and let us try to include the edge between V3 to V4 and weight of that V3 to V4 weight of that is 2. So now come here and mark this V3 as permanent. Now V3 is our current node. So from V3 to V5, V5 is the only temporary node available now. So V3 to V5, is there any direct edge? We are going to see. There is a direct edge, but the weight of that is 8. Whereas from V4 to V5, the weight is 4. So we are not going to change this weight because 4 is lesser than 8. So we are going to have V5 node in our minimum spanning tree, but the edge between V4 to V5 is going to be considered. So we are going to consider the edge between V4 to V5, not V3 to V5. So V4 to V5, we have weight of 4 units. So this is going to be our minimum spanning tree. The edges that are included in minimum spanning tree, V1 to V2, V2 to V6, V6 to V4, V4 to V3, V4 to V5. Hope you understood this.